Okay, so the next question 20, is all about factorizing quadratics. Now, as you should know, factorizing means put into brackets, and because we've got an x squared, we've got a number of x's and a number, that means going to put it into two brackets. So what we do is we open up the two brackets, and the first thing is what multiplies together to make x squared. Now that's always going to be x and x. The only time where it might vary slightly is if you had 2x squared plus a bunch of things, in which case one of them would be 2x and the other would be a single x. But in this case we've just got a single x squared, so it's going to be x times x. Now the next thing is we have a look at this last number here, which is 27, if I hadn't just covered it. So 27, so we need to find out what multiplies together to make 27. So you've got 1 times 27, 2 doesn't go into 27, so 3 times 9. 4 doesn't go into 27, neither does 5, 6, 7 or 8. The next number after that is 9, which we've already got. So now it's which one do we use? Do we use 3 and 9, or do we use 1 and 27 to make this bit in the middle, which is minus 12? Now, because we can't use 1 and 7 to make 12, we're going to ignore that one. We can use 3 and 9 to make minus 12, and the way we do that is we do minus 3 take away 9 to make minus 12. So there we go. Let's factorize into two brackets. X minus 3, x minus 9. Now the next part of the question is very much linked to this. So they've asked you to solve x squared minus 12x plus 27 equals 0. Now the wrong step that a lot of people make is they try to do x squared minus 12x equals minus 27, then that's where they get to and they leave it. That is the wrong method. What you need to do is, if you're ever asked to solve this where you've got x squared, something x and a number equals 0, the first thing we do is factorize it, which we've already done in the first question. So we factorize that. Rather than writing out x squared minus 12x plus 27, we write out x minus 3 and x minus 9 equals 0. Now what we've got here essentially is two things. We've got this multiplied by this bracket, and if you're going to set two things multiplying together to make 0, one of them's got to be 0. So what we do is we substitute in the value of x and find out which values of x we substitute in to make each bracket 0. So for instance, if we substituted in x equals 4, then this first bracket, 4 take away 3 would be 1. This bracket, 4 take away 9 would be minus 5. 1 times minus 5 certainly isn't 0, it's minus 5. So what we've got to do is we've got to find what values of x we can substitute in there to make each bracket 0. So this bracket here, if we substitute in x is 3, that's going to be 0 times minus 6. So the answer for the first bracket is x equals 3. The answer for the second bracket is x equals 9. So the answer that we're looking for here is x equals 3 and x equals 9. Now the next one, y squared minus 100. Now you should know that factorize means put into brackets. But if we have a look at this, there's nothing that we can take outside the brackets, because we've got a y squared here, but there's no y's in the second part. There's no numbers that go into both of them. But one thing that is common in both of them here is that they're both something times by itself. So this is y times by itself, and this is 10 times by itself. If that's the case where both of them are square or things squared, then what we call it is the difference of two squares. And it's very hard to pick up on, but if you can, you do get the extra mark. So what we do is we do y times y equals y squared. 10 times 10 excuse me, is 100. And you make one of them positive and one of them negative. And the reason for that is, if we use the smiley face method to multiply it out, y times y would be y squared. 10 times minus 10 would be minus 100. And the nose would be plus 10y. The mouth would be minus 10y. And 10y take away 10y, this part here would cancel out, leaving you just with y squared minus 100. So the final answer is y plus 10, y minus 10. Okay, the next question is question 21. Now certainly in both my year 11 classes, no one knew how to start this one. And I'm not surprised because it is probably one of the hardest questions on this paper. But the way we start it is, if you've got to prove algebraically that the difference between the squares of any two consecutive numbers is equal, we've got to think what that means. So what we're going to do is we're going to think of any number, and we're going to call that, we call it any letter we want. Let's call it n. So if n is any number, the next number after that would be the next one. So you find that by adding 1. So this is any number, and if this is any number, the next one consecutive, which means the one after it, would be n plus 1. Now what we've got to do is we've got to find the difference of the squares of any two consecutive numbers. So the square means that I times this number by itself. So if we do that, the square of n is going to be n squared. The square of n plus 1 is going to be n plus 1 squared. So first of all, let's figure that out. So n plus 1, if you've ever got a bracket squared, then you write it out twice. So n plus 1 times n plus 1. If you use a smiley face or whichever method you want to for that one, you end up getting n squared plus 1 plus n, which simplifies down to n squared plus 2n plus 1. Now, what we were asked to do is we've got to work out the difference between these two. So the first one squared is the second one squared is n squared plus 2n plus 1, and the first one squared was n squared. So the difference would be the second one take away the first one. Now if we do that, n squared take away n squared goes, then we've got 2n plus 1. So the difference between the two squares is 2n plus 1. Now what we've got to do is we've got to prove that that's equal to the sum of these two integers. So the sum means when they're added together. So the two numbers we were talking about were n and n plus 1. And hopefully you should be able to see that n plus 1 is 2n plus 1. So therefore, they're the same. So, right, therefore, they are the same. Now, I'm not thinking for 1 second that you'll be able to watch this part of the video once and completely understand that. But what I want you to do is go back and just watch one little bit at a time. See if you can pick up anything that we've said. So if we go back through the question, we've got to find the difference between the sum of two consecutive numbers or integers. So the first thing is finding out what two consecutive integers look like. And you're going to get 1 mark for knowing that the numbers are going to be n and n plus 1. So those are going to be your consecutive numbers. You've then got to work out what the squares of these are. That means the numbers times by themselves. So the first one squared is n squared. The second one squared, you've got to put it into brackets and then square it. And that's what we get here. And most people in my classes can do this. This is something that we've done loads of times. But it's about knowing that this is what we've got to do. Once we've done that, we just work through it systematically. So we've got to do the difference between these two things. So the difference between n squared plus 2n plus 1 and minus n squared, which simplifies down to this 2n plus 1. And the two numbers are added together, which are n and n plus 1, give the 2n plus 1. Like I said, that is the hardest question on the paper for me, which is why I think that one is the A-star question. But if you've seen a few of them before, then you can start to pick up marks. Remember, this isn't necessarily about getting 100% in your exam. It's all about getting an extra 1 or 2 marks here and there to make sure that you get up to your next grade, whether that's a C, whether it's a B, an A, or an A-star. The next question, again, this is something that is or certainly a lot easier than the previous question, and it's something you can do without an awful lot of practice. So we enlarge the shaded shape with a scale factor of -1/2 with center -1, -2. So let's start off finding the center of enlargement, which is -1, -2, which is here, because we go -1 across, -2 down. And we've got to enlarge this shape here by a scale factor of -1/2. Now, if we take a -1/2, take the scale factor into 2 parts. The first bit, minus, means that we do the opposite. So for instance, if we count from our center to this point here and we go right and then up, When we enlarge it, we're going to go the opposite, so we're going to go left and then down. And the half just means that instead, if we were to count two across and then 10 up, we'd halve that and count 1 across and 5 up. So let's see how this question goes. And again, this is a question that you can pause, rewind until it's something that you're completely happy with. So what we do, just like we did with the earlier question, when we're reflecting stuff, we're going to choose all 4 corners of our shape. Now, enlargement is all about counting. So to get from this point here to this point here, we've had to go to the right 2, then up 1, 2, 3, 4. So we've gone to the right by 2, then we've gone up by 4. Now, where that point's going to end up when we enlarge it by a scale factor of minus a half, we're going to go the opposite direction. So we're going to go to the left, and we're going to go down. And because we're halving it, it means that we're going to do half the numbers. So instead of going to the right by 2, we're going to go to the left by 1. Instead of going up by 4, we're going to be going down by 2. So we go back to our starting point, our centre of enlargement. We go to the left by 1, we go down by 2, and that's that point there. So this point here ends up over here. Then we do the same for the other points. So this point here, we count 1, 2, 3, 4, 5, 6 to the right, and 1, 2, 3, 4 up. So if we do the opposite and we halve it, that's going to be 3 to the left and 2 down. So we go back to our starting point and we count 1, 2, 3 to the left, 1, 2 down. That's going to be there. Now this point here, which we just plotted, is connected to this point here. So again, we go back and we do the counting. So that's going to be 1, 2, 3, 4, 5, 6 to the right, 1, 2, 3, 4, 5, 6, 7, 8 up. So 6 to the right, 8 up, which if we halve and go in the opposite direction, it's going to be 3 to the left and then 4 down. So go back to our starting point, which is right here. 1, 2, 3 to the left, 1, 2, 3, 4 down. And we're then going to join it to our final point, which is this one here. So again, it's all about counting. So we go 1, 2 to the right, and then 1, 2, 3, 4, 5, 6 up. So if we're going to halve that and go in the opposite direction, that's going to be 1 to the left, and it's going to be 3 down. So 1 to the left, then 1, 2, 3 down, gets us here. And that's it. 3 marks, which they're A-grade marks, but it's something that I think everyone can access. So, next question. Again, now this question was a little bit harder. And the hardest part about this question was knowing that you had clues at the front of your paper. So we've got a diagram that shows a solid hemisphere, which is half of a sphere, which is half of a 3D circle or a ball. We're going to find the total surface area. So here we've got 2 sides. We've got the outside of the ball, which is this bit here, and then we've got the circle, the flat circle underneath it. So what we've got to do is we've got to work out the total surface area. So if we have a look over here, and this is found at the beginning of your paper, the surface area for an entire sphere is 4 pi r squared. But we don't want the entire sphere, we only want the outside of half of it. So what we're going to do is we're going to divide this by 2, leaving us with 2 pi r squared. So that's going to give us the outside, which is this part here. Then we've also got the flat circle underneath. And you should know that the area of a circle underneath is going to be pi r squared. Now, what we've given here is that we're told that the radius is 5 centimeters. And the other thing, it says give you an answer in terms of pi, which means that we don't need to press a pi button on the calculator, which is a good job because we don't actually have a calculator. So what we're going to do is we're going to substitute in the radius as 5 centimeters into our equation here. So we're going to do 2 pi, and instead of r squared, r is 5, so 5 squared is 25. So 2 pi times 25 plus pi times r squared, and we know that r squared is 25. it 2 pi times 25 plus pi times 25. Well, 2 pi times 25, 2 times 25 is 50, so that's 50 pi plus 25 pi, which if we simplify that goes to 75 pi. And that's what we put as the answer. The hardest part about this is knowing that we've got this in the front of our paper that will help us with the surface area of a sphere. If there's anything that you don't know, that you think that you've never heard of before, always check the front of the paper. Okay, question 24. Now, this is a tree diagram question, and there's certain things that give it away that's a tree diagram question. First of all, it talks about probability. So we've got a probability question, and we've got to find out probability that she takes 2 different types of sandwiches. Now, there are choices, there are 3 choices. She can either take an egg sandwich, a cheese sandwich, or a ham sandwich. And she's going to do this twice. So if it's a probability question, with choices, and she's going to do it more than once, chances are it's going to be on a tree diagram. So what we do with tree diagram questions is we start off with a single point. And the first choice you're going to have is the first sandwich. So she's either going to take an egg sandwich, she's either going to take a cheese sandwich, or she's going to take a ham sandwich. What we're going to do is we're going to write down these probabilities. So the probability that she takes an egg sandwich is 4, because there's 4 egg sandwiches, out of a total of 11, because there's 4, 5, and 2 sandwiches. So that makes 4 plus 5 is 9, plus 2 is 11. So there's 11 sandwiches in total. The probability that she takes a cheese sandwich is 5 out of 11, because there's 5 cheese sandwiches out of 11 in total. And there are 2 ham sandwiches. And right here, this is the first sandwich. So this is sandwich 1. Right, okay, so we've then taken our first sandwich. So if we've taken an egg sandwich first, we've still got some egg sandwiches left because there's 4 to begin with. So if she takes out a second sandwich, she can still take out an egg sandwich, she can take out a cheese sandwich, or she can take out a ham sandwich. And she's got those options, doesn't matter what sandwich she chose first of all. So even if she chose a cheese sandwich first of all, she could then still take out an egg sandwich, she could still take out a cheese sandwich as a second, or she could still take out a ham sandwich as a second sandwich. Exactly the same for the ham sandwich. So she can either take egg, cheese, or ham. And now what we've got to do is we've got to work out the probabilities of these. And this is where it gets a little bit tricky. This is why it's towards the end of the paper. So if this person took an egg sandwich first of all, then therefore there's only going to be 3 egg sandwiches left. So we've gone down the first path here, which is the egg sandwich. So there's only 3 more egg sandwiches left, so that's going to be 3. But because she's already taken a sandwich, there's only going to be 3, 5, and 2 sandwiches left. So there's only going to be 10 sandwiches left, so that's going to be 3 out of 10. There's still going to be 5 cheese sandwiches, so 5 out of 10. And there's still going to be 2 ham sandwiches, so it's 2 out of 10. However, she doesn't have to take an egg sandwich. She could have taken a cheese sandwich. So what we're going to do now is we're going to find the probabilities if she'd taken a cheese sandwich first of all. So let's say she takes a cheese sandwich. Therefore, there's only 4 cheese sandwiches left. So therefore, there are still 4 egg sandwiches. But because there's 4 egg, 4 cheese, and 2 ham, there's still only 10 sandwiches because we've already taken one. So the egg sandwiches will be 4 out of 10. There'll be 4 cheese sandwiches, which will be 4 out of 10. And there's 2 ham sandwiches, which will be 2 out of 10. Okay, so what about if she took a ham sandwich first of all? So if she took a ham sandwich first of all, then she wouldn't have 2 ham sandwiches left. There'd only be 1 ham sandwich in there. So there'd still be 10 sandwiches because you've got 4 egg, you've got 5 cheese, and there's only 1 ham sandwich if she took a ham sandwich out first of all. So therefore, you'd have 4 out of 10 for egg, we'd have 5 out of 10 for cheese, and we'd have 1 out of 10 for ham. Now so far we've potentially just earned the 1 mark. However, if we've done all this, then it makes the next part of the question a lot quicker. So what we've just done here with this column is worked out sandwich 2, the second pick. Now what we've got to do is we've got to find probability she takes different type of sandwiches. So this one here is top one. She chose egg first of all, then she chose another egg. So we don't want that one because that's the same sandwich. This one she took egg first of all and then a cheese. So we do want that one. This option she took egg first and then she took ham. So they're different sandwiches. So we want that one. If we go down the next lot, the next one, cheese and egg, that's different. Cheese and cheese, that's the same. Cheese and ham, that's different. The next one underneath, ham and egg, that's different. Ham and cheese is different. The bottom one is ham and ham, which we don't want. So now what we do is we add up all the probabilities that we're after. So we want this probability, we want these 3 probabilities here, and we want these 3 probabilities here. So what we do is we calculate the probability of each one of those. And the way we do that is we multiply along the lines. So to get to this first option here, we went egg sandwich first of all, and then we went cheese sandwich. So that's 4/11 multiplied by 5/10, which leaves us with 20 over 110. The second option, we went egg first of all, and then we went ham, which is 4/11 times by 2/10, which is 8 over 110. This one here, we went cheese first of all, then egg, so that's 5/11 times by 4/10, which is 20 over 110. One thing I haven't said is that when you multiply fractions, it's dead easy. You just times the top 2 numbers, so 5 times 4 is 20, 11 times 10 is 110. Okay, and then we do the other ones, so that's going to be 5/11 times 2/10, which is 10 over 110. The next one is 2/11 times by 4/10, which is 8 over 110. And then we got 2/11 times by 5/10, which is 10 over 110. And then we add them together. When we add fractions, we do not add the bottom, we do not add the denominator. So we've got 20 plus 8 plus 20 plus 10 plus 8 plus 10. That's all going to be over 110. So 20 plus 20, 10 plus 10, 8 and 8. Those are all the numerators. So that's going to be 20, 40, 50, 60, 68, 76. So the final answer we're looking for is 76 over 110, which of course you can simplify down by dividing top and bottom by 2. 38 over 55. However, they haven't asked you to write it as simply as possible. So leaving your answer as 76 over 110 gets you all 5 marks. So if you can get 5 marks in the third from last, which we call the anti-penultimate question, then that's absolutely fantastic. That stands you in a really good stead to get your target grade. Okay, this one comes up, I'd say once every 3 or 4 exams, and it's transformation of graphs. So what we've got here is we've got to sketch a graph of y equals minus f of x. So f of x is just a function of x. It's just something that happens to x. So in this case, it makes our function makes it look like the letter u. Now, if we've got y equals minus f of x, what that means is that we reflect it. So when we reflect this, we're going to reflect it down, so it's going to look something like this. Obviously, if I did that, I'd get 1 mark for getting it roughly right, for making it look like a sad face, but I wouldn't get the second mark because it's not accurate enough. We're reflecting it in this line here. So the points that we've got to make sure that we hit are this point here, where it hits the axis. Now this one here is 1 point above the x-axis, so that's going to need to be reflected down there. This point here, we can tell which coordinate that is. That's 0, 4, so that's 4 above this line. So go 4 below that line. That's there. Other coordinates that we know are this point here, this coordinate, and this coordinate. So we reflect these points, and that's going to go there, and it's going to go there. And then, as long as your curve goes through those points, then you'll get the marks. So this one is just a matter of memorizing that if it's minus fx and the minus is outside the brackets, it's reflected like it has been in this question. One rule of thumb is that, because the next one, this one has been moved, so from y equals f of x here, it's gone over to the right, to over here. One rule of thumb is that if you've got f of, and then we've got x, if anything is put inside the brackets, it means it's going left and right. If anything's put outside the brackets, so for instance at +4 on the outside, that means it goes up and down. So one thing to remember, and it's worth writing this down in notes for if you're doing revision on this, is inside the brackets, stuff moves left and right. Outside the brackets, stuff moves up and down. So for this one here, for what I mean by this, is that this one here, y equals minus f of x, the minus sign is outside the brackets, therefore gets reflected down. For this question here, for question B, it's been moved to the right. So we say that y equals f of x, and if it's been moved to the right, we say it's going to be minus 6. Inside the brackets is always back to front. So if it's been moved to the right, by 6, we say minus 6. If it's been moved to the left by 3, we say y equals f of x plus 3. It has it in this case. It's been moved to the right by 6, so therefore it's going to be y equals f of minus 6. Okay, and our final question, you'll be delighted to hear, is question 26. Now we've done a bit of work on this already, but this wasn't one of the easiest questions. But I know a lot of people picked up marks for part A. So we've got to express the journey from A to B. Now the roads that we can see, we can go this road here, and we can go up this road here. We can't go up this road because we know nothing about it. But the stuff that we do know is that this road down here is 3A, and this road here is 6B. But we've got to be careful because it's a one-way street. So this road's going this way. So if we want to go the opposite way, if we're going to go from A to O, that's going to be minus 3A. Then we've got to go along the direction of this road up here. So it's going to be plus 6B. So minus 3A plus 6B gets our first mark. And even if we just get the 1 mark there, it's certainly better than getting no marks. Okay, so the next one here, we've got to prove that OX, going from O to X, equals 2/5 of going from O to Y. So, again, most people left this blank, but let's see if we can pick up just some marks. So first I need to know how to get from O to X. So here to here. Now one thing that we're told is that AX, or AX to XB, is in the ratio 1 to 2. So what that means that if you've got AX here and XB here, that's breaking down, so that's 1 part and that's 2 parts. So the overall journey from A to B is 3 parts. And because A to X is 1 part of that journey, then we can say that AX equals 1/3 of AB. Now we already know what AB is. AB is our answer here. So we can say that AX equals 1/3 of that journey. Now 1/3 just means dividing it by 3. So we can say that AX equals minus 1A plus 2B. And now the next thing we've got to do is we've got to find out what two-fifths of OY is. So we know that AX is, so OX, sorry, we've just figured out what AX is. Now what we've got to do is we've got to figure out what OX is. So to get from O to X, what we're going to do, because we've just figured out what AX is, so we're going to go from O to A, and then A to X. So OX equals O to A plus A to X. Now O to A we can see is 3A, then A to X we just worked out down here as minus A plus 2B. So if we simplify that, we've got O to X equals 3A plus minus A, so that's going to be 2A plus 2B. And now we've got to figure out what 2/5 of OY is. So let's have a look back at our diagram. And to get from O to Y, it's quite a simple one. You go from O to B, and then we go from B to Y. And writing that down gets us 1 mark. So O to Y is 6B plus, and then the next journey from B to Y, which is 5A minus B. So if we simplify that, we get 5A, and we get 6B take away B, which is 5B. Now going back to what we've got to prove, we've got to prove that OX equals 2/5 of OY. So we can say that OX equals 2A plus 2B. OY equals 5A plus 5B. So 1/5 of OY equals 1/5 of this. So that means dividing it by 5. So 1/5 of OY is A plus B. So 2/5 of OY equals 2A plus 2B, which is the same. If you can do that, that gets you the 5 marks to round off your A star. Right, now you've got all the questions. What I suggest you do is that this shouldn't be the last time you watch this video. You've got exams coming up after Christmas. So what you need to do is watch this video, rewatch this video, rewatch it for a 3rd, 4th, 5th time. It's hugely useful to look at past papers and how the questions should be done. Look through the paper that you've got, so you should have 100% paper now. So just keep looking over it, keep going over every question you can, and hopefully you should see the difference in your grades pretty soon. Well done, boys and